Hi, everyone. Welcome to this edition of Project Pro's podcast on AI monetization, where we dive in depth into enterprise business outcomes and use cases on how AI is being leveraged. At Project Pro, we're obviously obsessed about how AI is increasing both the top line and the bottom line inside industries. And today we have with us somebody with over 10 plus years as a data scientist and then focused on NLP and currently leading GenAI. Gagandeep Singh, he's a staff general GenAI data scientist at RealPage, which is a large publicly traded AI-enabled software platform for the real estate industry. And at RealPage, Gagandeep has worked on a set of GenAI projects that showcased efficiencies from 40% to 90% productivity. Before this, Gagandeep was a staff data scientist at Walmart, and before that at Xerox and TCS. Gagandeep, thanks for taking time to do this.
Absolutely. Thank you for having me, Binny. I'm really excited to talk about my career and everything.
Thank you. Gagandeep, I thought we'd probably split this into two halves. In the first part, we could probably pick a specific use case that you worked on, deep dive into it. And on the second part of the podcast, we could talk about the team, the skills needed, upskilling, how does somebody join your team, and topics like that, if that's okay.
Absolutely.
Okay. So to begin with, Gagandeep, you had implemented a claims processing use case at one of your previous employers, Walmart, obviously the largest retailer out there. Could you help us understand what is a claims processor, which department, what does he or she do, the job role?
Okay. So, Billy, I was working in Walmart as a staff data scientist in Walmart claim processing team. It's called WCS, Walmart WCS department. So we basically handled claims like auto subrogation claims, auto liability claims, worker comp claims, and journal liability claims. So since it's a retail industry, so every employee or customer were liable to file a claim, be it worker comp, like if an accident happens during in the distribution centers or in a store, so a worker is eligible to file for a claim. General liability is for the general public, general customers. And auto liability claims are like when you see Walmart vehicles on the road, if they are in an accident, be it Walmart's fault or other party's fault, then auto liability claims come into the play. Yeah. So this whole department basically handles like thousands and thousands of claims in the basically three categories. So, I mean, being a staff data scientist in Walmart labs, I mean, I was given this responsibility because I had the experience in natural language processing, and being in claim industry means it involves a lot of unstructured data, like a lot of textual data. So since I had a lot of experience back in like with TCS and Xerox and in my grad school as well, so it was like a perfect opportunity for me to like automate stuff, to make it in a structured way, and how can I help Walmart in processing and automating a lot of textual claims into a structured manner. So to elaborate more, I mean, I would say like during my time at Walmart, I would say from August 2022 till January 24, I was deeply involved in upgrading the claims processing system using these advanced NLP models. To elaborate on one, the one that I mean, closely worked on was like a auto subrogation claims prediction, wherein we implemented a model text classification model using BERT, Google's BERT algorithm, to predict the auto subrogation claims. In my opinion, this was a massive undertaking because this involved a lot of analysis of over almost 1 million claim notes from the last 10 years. Like we had to figure out the patterns. The challenge here was not just the volume of the data, but I would say it's also the complexity and the unstructured nature of them. A lot of dirty data that we had to handle. So the reason we chose BERT, and just for the audience, BERT is like bidirectional encoder representation from transformers. It's one of the uh, state-of-the-art model back in like developed in 2021,
Mhm.
like after LSTM, like the upgrade version of LSTM because of the bidirectional nature. And we chose this for the stars due to its ability to understand the context and the nuances in the text. So the multimodal aspect of our approach allowed us to incorporate various types of data types using text, such as numeric fields, categorical data, to make, I would say, make more accurate predictions.
Mhm.
And to optimize our model, because we were using vanilla BERT at that point of time, and to like optimize our model for our own use case, we
Mhm.
conducted extensive A/B testings on different architectures.
Mhm.
And I would say this rigorous approach led to a 15% improvement in the classification accuracy also. And in the context of Walmart scale, and this improvement translated to millions of dollars in cost saving and significantly streamlined the subrogation process. So we were able to uh, predict like which claim will go into auto subrogation based on just the claim description as well. So that was
Mhm.
a really breakthrough for us. So uh,
Mhm.
and we basically, the goal for this particular project was not just to deploy and or employ this particular architecture for auto subrogation claims, but for other type of claims as well, because we had worker compensation, general liability. So each of these areas presented unique challenges and required a similar kind of and a little bit of required tailored approaches. So, but since we had this base architecture for one particular claim, we knew that it's going to help with other type of claims with just a little bit of tuning. Because
Mhm.
I remember in worker compensation, we needed to accurately categorize the nature and severity of workplace incidents. And for general liability, the challenge was like to understand the wide variety of potential claim scenarios, because it's not just genuine claims. There were a lot of fraudulent claims came into the play as well. And with this particular architecture that we developed for auto liability claims, uh, it allowed us to quickly assess the fault and potential fraud as well. So I would say by leveraging these advanced NLP techniques, we were really able to automate and extract relevant information from claim description, other kind of reports that we had internally, and from different data sources.
Mhm.
Uh, Eventually, I would say this not only sped up the claim processing, but also improved the consistency and the accuracy of our assessments.
Got it. There's so much very interesting stuff what you just said.
Yeah.
If I can just unpack this, and I have a few follow-up questions just to better
Mhm.
understand, Gagandeep. So the first is when you refer to auto sublocation claim, could you help us understand what does that mean in a business context?
Absolutely. So, in terms of claims department, auto subrogation means I'll explain it with an example. For instance,
Yeah.
let's say I'm driving my car and there is a Walmart vehicle on the road,
Mhm.
and
Mhm.
we somehow got into an accident.
Mhm.
So let's say I rear end Walmart's vehicle. So in this
Mhm.
scenario, Walmart is liable to get money out of my insurance coverage because it's my
Mhm.
fault. And
Mhm.
in terms of claims processing department, that means this particular claim will go into auto liability claim.
Mhm.
And subrogation means uh, Walmart is liable to get money out of my insurance coverage. So subrogation is a technical term that basically claims department utilize in this scenario. That's all.
Got it. Okay. And then, the Walmart claims department gets a claim, and I'm assuming this claim is in a digital form. It's not a paper form, right?
So during the accident, when the accident happens, an investigator goes to the accident
Mhm.
sites and write
Mhm.
like a claim description. For instance, uh, giving you an example, like Gagan rear-ended Walmart insured vehicle. So
Yeah.
this digital form of claim description goes into our system, and then
Mhm.
after this, my model kicks in and predicts and whether it's a genuine claim or like doing all the processing.
Okay. So there is no OCR involved here because the whole thing is digital. Oh,
So exactly,
yeah.
exactly, everything is
Okay.
digital. Yeah.
Okay. And then before your model came into picture, Gagandeep, how was this being done? What was the status quo for this?
Manually. Manually. We had claim managers. We have claim managers that were literally processing each and every claim manually, going through each and every detail. And that was
Wow.
taking a lot of time, literally a lot
Yeah.
of, yeah. So that was like a big through. I mean, big breakthrough in Walmart. So I'm really proud of
I,
the team and myself being part of that.
it's amazing because this is one of those typical enterprise level problems that exist inside
Exactly.
large enterprises, like a car rear-ending a
Exactly.
Walmart truck and a workflow to
Yeah.
manage that whole thing, right?
Yeah.
Yeah,
Exactly.
it's a beautiful use case actually. Um,
Yeah.
so I'm assuming at Walmart scale, we are talking about hundreds of such claims a week, thousands, like
Thousands,
thousands.
thousands. Yeah.
Okay, okay,
Because it's not just in US, it's in
yeah,
Canada, Philippines, and other countries as well. So it's been
got it.
processed all over the world.
Yeah. And then this, before your model came in, this claim handler looking at this, his or her job role is to look at this and categorize this
Yeah.
into genuine, not genuine, or are there more categories to these things?
Mo- Basically, if it's vehicles, if the vehicles are involved, then
Mhm.
again, I mean, by default it goes into auto liability claim, and then the whole
Yeah,
investigation happens after that, whether it's a genuine or not, and then all the claim processing, like as I mentioned, like how I utilize an LP to
yeah,
extract some vital information from these documents. So this was all done manually by the claim manager.
yeah. So there seems to be two things here. One is understanding what's in the form and also kind
Mhm.
of replicating the business logic that goes into the handler's head. So
Mhm.
was that was or is most of the work on just understanding the form, or was there a ton of business processing logic as well involved?
So it's the documents that I mentioned was like claim description, like
Yeah,
what the investigator writes. So there were
yeah,
other internal documents that were
mhm,
provided to us or provided to the
yeah,
claim managers before the
yeah,
model. So like
mhm,
some kind of police reports or some other like unstructured textual data. So
yeah.
these all were involved in processing these claims. So
Understood.
my job was to basically extract relevant information and provide in a structured manner and give a summary. Provide did some initially we did some custom name entity recognition models also, like to provide extract some provider details from the Walmart claim notes. What since when it comes to the claim managers, they also write, or when the investigation happens, uh, reporters also write some notes with respect to the accident. So we had like data sets of hundreds and thousands of records, so each containing complex and structured text.
Okay. Okay. And you
Yeah.
mentioned that you kind of finally chose BERT as your model because of its, bidirectional
Yeah.
nature, so that you can factor in the context. What were some
Mhm.
other contenders you were considering as alternatives to BERT, or is BERT a clear choice?
Initially, we were thinking of leveraging like traditional ML algorithms, and also like the really good like LSTMs, bidirectional LSTMs also exist. But
Yeah,
BERT being the state of the art at that point of time,
yeah,
and it because of the attention mechanism that it already has.
yeah.
So I think that was like a clear win. But I tested out different models as well, like
Mhm,
LSTMs. I thought
mhm.
like we could also leverage some traditional ML algorithms that can also help in this, utilizing some traditional like TF-IDF, BM35 embeddings. But in my opinion, when we tested it out, BERT was a champion model, and that's why we went through with that.
Very interesting. And just as a tangential topic, the LLMs are the hottest topic today. But is BERT a LM or is it an LLM? I mean, where does it? Is it a language
So
model or is it a language?
since the I mean, the beginning of all these LLMs and everything, I mean,
Yeah,
transformer model is the core transformer
yeah,
architecture, both the
yeah,
encoder, decoder. So in my opinion, I would consider BERT as a large language models because it utilizes transformers decoder only part because it's
yeah.
bidirectional. Sorry, encoder part, not the decoder. So bidirectional encoder representation of transformers. So in my opinion, I would consider it because it's a really big breakthrough back in 21, 22. So to make a distinction, like I wouldn't consider it as big as the models like GPT-3 and GPT-4, but
Yeah.
although it shares the similarity and I would say a precursor to modern LLMs.
Mhm.
I mean, because BERT uses transformer architecture, which is also the basis for many LLMs. But
Yeah.
however, I would say BERT is primarily designed as an encoder model for understanding and representing the language rather than
Mhm.
generating it. So it's
Mhm.
bidirectional, meaning it looks at the context on both sides of the word when processing the text. And LLM like GPT-3, on the other hand, are typically decoder models or encoder decoder model designed for both understanding and generating text. So, in my opinion, I mean, they are usually trained on much larger scale and are more capable for large, diverse language tasks.
Yeah.
And while I would say like BERT is a large model by the standards of its time,
Yeah.
like with versions ranging from 100 million to 340 million parameters,
Mhm.
but it's much smaller than what we typically consider LLMs today.
Yeah.
Because modern LLMs often have billions and even trillions of parameters, like, and I mean, almost like Llama 3.1 just came out like 2 weeks back, and it's almost 405 billion. It has 405 billion parameters. So in that scenario, it's a big deal. I mean, back in the day, it was really good. I mean, still, I mean, for the traditional NLP tasks like sentiment analysis, text classification, I mean, first choice is this because it's free, open source. You don't have to pay anything for that.
Yeah. Yeah.
And
Okay.
so,
And keeping the cost factor, managed service model or open source model, keeping that aside, if you were working on a claims handling case today, would you still use BERT? Would you say a GPT or a Llama is an overkill? Would you still go with BERT?
I would say I would definitely try out the modern LLMs as well, like GPT-3
Yeah.
or Llama, to
Mhm.
understand like how much it can save. I would definitely do some cost benefit analysis first
Mhm.
to understand like what's the benefit we are getting of using these modern LLMs versus BERT
Yeah.
being the open source and free. If
Yeah.
there is a huge difference, I would definitely consider going towards the modern LLMs because
Mhm.
if why not? I mean, it can save us money as well as time, then why not?
Yeah.
So because it takes a lot of time to fine tune a BERT model as well.
Yeah.
So
Makes sense.
I would say,
And since
yeah.
since you spoke about fine tuning, Gagandeep, I would love to understand a little more on that topic for this use case, right? Um,
Mhm.
what kind of fine tuning did you do, and how many instances of sample data did you need to kind of get a acceptable output?
So okay, in terms of fine tuning for my particular use case at Walmart, I
Mhm.
mean,
Mhm.
it was, in my opinion, this was an excellent opportunity to
Mhm.
basically dive deeper into the practical application of these NLP techniques. Uh, in my case, for auto subrogation claim prediction, it was a bit complex and multifaceted process. So the first step was to understand the tasks, and so the primary goal was to predict, as I mentioned, like the auto subrogation claims based on claim
Yeah.
notes and other
Mhm.
documents, right? So
Mhm.
this involved analyzing almost like almost a million claim notes, and
Mhm.
each containing almost rich unstructured text data about auto accident damages and these kind of stuff.
Mhm.
And one of the challenges was to train the BERT model to understand the specific language and the context of auto insurance claims,
Mhm.
which involved a lot of industry jargons like legal
Mhm.
terms and some detailed descriptions of accidents and uh, some internal abbreviations that Walmart utilized. So before fine tuning, I would say we had to pre-process our data carefully. Like we cleaned the textual data, and removing any personal, like PII information. PII stands for personally identifiable information to ensure like the privacy is it's privacy is compliant. And
Mhm.
we standardize formats for dates, currency amounts, and these kind of unstructured fields within the unstructured text. And we tokenize the text using BERT's specific tokenizer, which splits words into subwords, allowing it to basically handle out of vocabulary terms efficiently.
Mhm.
Then I would say adapting BERT for this multimodal input,
Mhm.
since its BERT is primarily designed for text. but our use case required a multi-modal approach. So we enhanced the model to incorporate both textual and structured data, both numerical data as well was also considered. And so for textual data, like the claim description, we use BERT standard input format. And for the structured data, like amount, age, other type of variables like vehicle type, we created additional input features, and we designed some kind of custom architecture where BERT's output was concatenated with these additional features before the final classification layer. And during the fine-tuning process, we used like a pre-trained BERT model. Started with like a BERT base, and then we fine-tuned it for our specific use case. Like we added a classification head on top of BERT's token output. And then I guess, I believe we carefully chose hyperparameters, including like learning rate, batch size, number of epochs. And because given the large data set, we likely had to use a relatively small learning rate and large batch size to stabilize the training process. And then we implemented gradient accumulation to effectively increase the batch size without exceeding the GPU memory limits, because we were utilizing some of the GPUs. And we used techniques like, I remember, like learning rate, warm up, and decay to optimize the fine tuning process. And since we were dealing with a lot of claims and handling class imbalance was one of the case, and since subrogation claims are typically a small percentage of the total claims, so it led to class imbalance. So we experimented with techniques like oversampling the minority class, undersampling the majority class. We also used class weights in the loss function. We also tried focal loss, which is particularly effective for imbalanced classification tasks. And when we dealt with long text, like claim notes often exceeded BERT's maximum input length of 512 tokens, right? So we experimented with different truncation strategies, including truncating the maximum length, using sliding window approaches to capture information from longer documents. We also tried and tested like hierarchical approaches, where we would process long documents in chunks and then aggregate the results. So that was like a whole process in developing that. Then again, A/B testing happened, then evaluation and iterations, like quantitative metrics, including accuracy, like all the traditional precision recall F1. We basically particularly focused on the performance of the subrogation class. Then we also made sure that qualitative evaluation were involved by working closely with claim adjusters and claim managers to review model predictions and understanding the edge cases. So based on these evaluations, I would say we iteratively refined our model and adjusted the features, hyperparameters, and even the reframing the problem when necessary.
That's very, very interesting. One of the things you mentioned was you built a classification head. Could you maybe just help us understand what you mean by that specifically?
Okay, so to elaborate more, because it was a classification problem, since the use of a classification head in fine-tuning BERT for our specific use case was a crucial aspect of adapting the pre-trained model to our particular problem, right? So I would tell you like what's the importance of this in our context. So is the classification head is an essential, I would say, a component when fine-tuning BERT, or I would say a similar pre-trained model for classification tasks. So the purpose of this classification head is essentially it's an additional layer or a set of layers, I would say, that is added on top of the pre-trained BERT model. It basically its primarily purpose is to transform the high dimensional representation learned by BERT into specific outputs. In our case, it was the prediction of auto subrogation claims. So in the pre-trained form, I would say the BERT model, it's a general purpose language model as BERT it is. And BERT has already learned to understand the language context and semantics, but it is not inherently designed for any specific task or downstream tasks like classification. So the classification head allows us to leverage BERT's language understanding capability for our own specific use cases. In this case, it was a classification problem. So
Okay.
the classification head basically might be a single dense layer with softmax activation, like for multi-class classification, or sigmoid activation for binary. But however, depending on the complexity of the task, it could involve multiple layers, dropout for regularizations, or some, I would say, like architectural choices. So it's basically utilizing the CLS token that's like a specified label, like a CLS in parentheses, that is like a special token at the beginning of each input sequence. So we use
Got
these
it.
CLS tokens to represent input to our classification head. Yeah.
Got it. Got it. And just one final question on the fine tuning. As you
Mhm.
went about your data preparation, was labeling
Mhm.
something you encountered? Was it manual, or did you have pre-labeled data? Um,
So we had a lot of pre-labeled data, and
mhm,
some of the data that wasn't pre-labeled, we already had a team of
mhm.
labelers that helped us label those data. So labeling was not a big deal. I mean, because we had subject matter experts who helped us label those data.
Mhm,
We utilize AWS ground truth to label those
mhm,
data, uh,
mhm.
and it made our work easy, to be honest, at the end of the day.
Understood. Got it. Got it. And I assume you use AWS as your infrastructure to run this and fine tune and deploy this?
So no, I mean,
No.
we utilize Azure to deploy these
Azure.
models, but
Okay.
AWS had already built in AWS ground truth, so we utilize that for the labeling processes.
Okay. Okay. Great. Now, so the final business outcome here is the number of claims being handled by the average claim handler significantly went up.
So the overall outcome of the auto subrogation claim prediction project was
Mhm,
to first of all improve the classification accuracy, like uh, whether a particular claim is liable for auto liability claim processing, in the sense that uh, the most directly, I would say, the measurable outcome was like we could see uh, more accurate identification of claims that is eligible for subrogation, reduction in false positives, that claims incorrectly flagged for subrogation, and false
mhm,
negatives that were like
mhm,
missed subrogation claims opportunities. We also saw like increased confidence in the automated system recommendations as well. Uh, in our case, we also saw the implementation of advanced predictive modeling led to significant improvement the operational efficiency, like faster claim processing time, as it's an automated process now. Reducing manual review for claim adjusters, that allowed them to focus more on complex cases, and more consistent application of subrogation criteria across larger volume of claims. And at the end of the day, I mean, it all boils down to the cost saving. So while it's not explicitly stated, but at the end of the day, every project boils down to cost saving. So we reduced a lot of operational costs due to more efficient claim handling now, and potential reduction in overpayments on claims that should have been subrogated.
got it. And both at this use case at Walmart and currently at Real Page, what are some of the challenges that you find deploying large language models?
So, in my opinion, the the biggest challenge that we face right now is the latency,
Mhm,
because with with all these large language models, sometimes when the architecture gets complex, be it RAG architecture, be it agentic frameworks, the latency to get an answer with all the different complex architectures that we already have, that is the biggest challenge, I would definitely say. And then choosing the right model for the right project, considering the cost of these models as well. But luckily, with the advancement of these models with GPT-4 or Mini that just came out, I mean, they are cheap, and no doubt about it. Like, we're working on a current project for call intelligence at RealBridge, and we're thinking of going towards GPT-4 or Mini, because for 1 million call transcripts, just charge $540. So that's a big breakthrough as compared to almost $1,500 for the same amount. So it's like 50% reduction uh, in the cost. As I mentioned, like one of the key challenges with these are like computational resources as well, like because not just we're utilizing GPU resources, uh, it's just fine tuning them as well for some use cases, and the cost of running these inferences on in production environment can be substantial. So I mean, considering the high volume of applications. So then one of the things that the challenge I have faced a lot were hallucinations, on the factual accuracy of these large language models, because LLMs can sometimes generate plausible sounding but incorrect information. I have seen a lot of use cases, and I know like we tried and tested a lot of different techniques to reduce hallucinations, like implementing fact checking mechanism, using ground truths to check how much accurate our model's output is with respect to the actual output that we want. Uh, Check ensuring that factual accuracy is being maintained in the generated response. Then one of the biggest challenge I faced was like the context window limitations, because many LLMs have limits on the amount of context they can process. Because this can particularly challenging an application that requires a lot of long-term memory or processing of lengthy documents. So again, but with the advent of all these, one of the challenges I think now we can face is the interpretability and the explainability of these models, right? Because we're just working with the black box models right now, and it's really hard to see the like how the model performed these, right? Because in traditional ML algorithms, we could literally check like in decision trees, random forest, we can literally check why
By step.
this
Yeah.
mod step by exactly like why this output came. So
Mhm.
how this particular variable is being affected by the input variables, right?
Yeah.
So I would say like the lack of interpretability can be problematic in the
Okay.
industries right now. And yeah.
Okay. Again, there's so much good stuff you just said. I just have a few questions to unpack it. So the first one is the latency that you talked about. So do you think
Mhm.
latency is going to be solved uh, on the hardware side, or do you think it's going to get solved using small language models, the so-called SLMs? How do you think latency is going to get solved?
So in my opinion, like addressing latency issues in these is like a critical challenge. So I would say
Mhm.
like uh, at the industry level, we can explore different strategies to solve these and mitigate latencies. In my opinion, we can do some model optimization techniques as well, like reducing the weights, like from 30, like quantizations in a technical term. So reducing the precision of the model weights from like 32 bits to 8-bit. Uh, this can this technique, I would say, can be particularly effective in using GPUs, as modern GPUs have and are becoming more advanced and have specialized hardware for low precision computations. And I would say like uh, what I can think on out of like on top of my head was like pruning, like removing less important weights or entire neurons from the model that can reduce its size and computational requirements as well. Some of the techniques I can think more are like as you mentioned, like with more GPU, like more advanced GPUs that we have more inferences on clouds that we have. It's getting a lot of popularity these days. Like Grok one is one of the company that I know is doing a lot in this field,
Mhm.
and so I can think that having advanced GPUs, pruning, knowledge distillations. I would say like having an efficient model architectures. Uh, Again, I mean, since we can leverage specialized hardware that can significantly reduce like GPU optimizations. Like we can work with like current industry trends are like most of the fine tunings are happening on NVIDIA H100s. We can utilize other GPU, advanced GPU models right now as well. since I've worked with NVIDIA T4 GPUs for fine tuning these use cases and ensuring these optimal use of GPU memory and to compute and the compute capabilities I would say, is a crucial for low latency inferences. But I guess with a combination of GPUs and TPUs, I think it can be done. And there are multiple techniques like inference optimizations that we can also utilize, like batching, caching as well, like for implementing caching mechanism for frequent or similar queries. Because I believe we implemented this in one of our use case at RealPage to that users are typically questioning the same thing. Then we cache those similar queries to significantly reduce response times with the old models like GPT 3.5 Turbo. And we also utilize parallel processing, like model parallelism or pipeline parallelism to distribute computation across multiple devices. So then if we talk about like models, like we can also like talk about some few short learning, prompt compressions. There are multiple techniques that I think can be utilized and experimented with in terms of low latency.
Okay. And you might already know this, but I came across this company last week because one of our investors, Sequoia, had funded them. They're called Fireworks, and they,
Okay.
I mean, there's a bunch of literature there claiming them to be the fastest inference out there for LLMs.
Oh, nice.
Yeah, so just to bring it to your radar, the company is called Fireworks.
Fireworks, okay.
Fireworks, yeah. And the second problem you mentioned, Gagandeep, was hallucination, and you talked about grounding it and then comparison to kind of eliminate. And by grounding, do you mean RAG? Is that what you're referring to by grounding, or
no? Grounding means like as I mentioned, like AWS has a ground truth mechanism, right? So we create it. So we have manual labelers here who we use to make golden answers, and so that we can compare the LLM generated response with the original answers or the golden answers to check how much our model is hallucinating.
Yeah, makes sense.
Yeah.
Okay. And just kind of transitioning into kind of the team that takes to build awesome solutions like this. The claims handling case we discussed. What kind of a team and how long does it roughly take to build a solution like that?
You mean to say like the technical team or the whole Walmart claims department?
No, the technical team which that build the data science solution. How many people and how long roughly?
So we had a team of 4 people, 3 data scientists, 2 data analysts in our team that basically made this project through. Most of the data analysis was done by the data analysts, and all the groundwork on the modeling front was done by the data scientists. And one of the best thing about Walmart and our team was that it's not just because we were data scientists and we were just doing modeling. So a knowledge sharing sessions happen every week so that all the data analysts can be abreast with the latest trends and the modeling techniques that we're utilizing, so that they can also upskill themselves in the industry itself. So it's like a collaborative environment that we were in, and that's how we came up and developed the solution.
Got it. And how do you approach upskilling for a data science team? How does one think about it? I mean, there is the Udemy's and Coursera's of the world out there, but a lot of what you just told me right now, I'm sure is not in a Udemy or a Coursera course. So how does somebody learn all of this stuff? So basically learn how to fine tune a BERT for this specific.
Okay.
Yeah. How does one pick up those skills?
So in my opinion, like if you talk about the latest technological trends and the techniques that I mentioned, I mean, I believe you can find this anywhere over the internet. Like there are a lot of YouTube channels that are teaching like how you can fine tune large language models, how you can productionize these models. Having an hands-on projects is a big help in developing these skills. Like reading research papers, in my opinion, helps in upskilling yourself with the latest technological trends. And that's, I mean, if you see, we're getting everything, uh, something new every day. Like when I'm just, I've subscribed to a multiple newsletters, and when I read these letters, I see like every day we're getting new technology. We're getting new upgradations to these large language models. And I think something's happening in the Gen AI world every day. So keeping abreast with what's happening and implementing those in our use cases is one of my job responsibility as well. So I would say going through the courses, like one of the best resource that I found to understand or start with is like deeplearning.ai, that I believe it's a really good uh, platform to learn about deep learning, large language models, NLPs. Then there are a lot of YouTube channels, and then working on a real-time project, that's a big help as well. Like you can try out with Kaggle as well. Kaggle has a lot of data resources, open source data. I mean, play around with the data. That's all I mean, I can say, to be honest. And I would say find a mentor, like seek a mentorship from an experienced professional in the areas. That also helps a lot. I mean, that I was lucky enough to had mentors in my grad school that helped me with a lot of these skills that I have, especially my professors over there that helped me go through a lot of research papers and hands-on projects, research projects that I was part of that helped me get these knowledge on fine-tuning BERTs, how BERT works and everything. So that was a really big help for me. So
Got it. And what are your favorite
yeah.
newsletters to stay abreast of the developments?
So there are a bunch of them. Like
Mhm.
there is one that I particularly like is called Bay Area Times
Okay.
that I'm subscribed to. And there is one called AI Weekly Check-in that
Okay.
basically gives you all the updates on AI that's happening, whether a
Mhm.
company is acquiring something, what's the latest going on in the field of AI right now, whether a new model is coming, what's the best. Like the first thing, it gives you the knowledge, like it's really up to date. And every morning I read that before I start my work so that, I mean, I can share the same knowledge within the team as well so that everyone is on the same page. And one of the good things about our team currently is that we have these uh, weekly sessions on where we break down the research paper of our like somebody's choice, and we go through this paper and checks like how can we implement the same strategy for our use cases, so that we can also like be like at par with the industry and have provide our customers with the with the best in place technology that we have. So
Great.
because I mean we're not restricted towards having one particular technology that I experience in my past experience right now. So that is the best thing. I mean, with our team
Okay.
and the learning curve that we have. Yeah.
And as you look at the horizon of what is coming up, and with AI, the
Yeah.
horizon is probably next month or even one quarter from now, not even next year. What are you most excited about?
I mean, I'm particularly excited about how these, I would say, large language models are like expanding because
Mhm.
2 weeks ago, we had this Llama 3.1 with
Yeah.
405 billion parameters
Mhm.
and with long context window. I mean, I believe
Mhm.
the era of RAG is going away
Mhm.
because the traditional RAG is nobody's going to use that because the
Mhm.
context window is expanding so much that we don't need these traditional RAG architectures. I'm really excited about the use cases of a lot of agentic frameworks, like multi-agent frameworks, particularly line graphs, and how these are like advancing in the near future. I would say since we are moving towards AGI, as like Sam Altman also mentioned, like that's the goal of the whole AI right now. I mean, I want to see like how it can help people, companies in automating these stuffs a lot. I know it's already been done a lot, but I want to see like how we can utilize these AI and we can also like how we can teach these skills to the public, to the students, to the upcoming engineers or the students that can leverage these skill sets in the upcoming market, because we all know like the industry trend is changing a lot from the traditional coding now, traditional ML algorithms to these artificial intelligence algorithms that are so powerful and intelligent than the traditional ML algorithms. That, I mean, I want to see how we are going towards and advancing. Like, I'm seriously excited about the aspect of using these large language models, these AGIs, these land graph agents to be particular. So,
Okay. That's fantastic. And just one final question, Gagandeep, since you brought up the topic of agents, right? So I'm curious,
mhm,
right? If you take that claims handling workflow that you spoke about so nicely, are
mhm.
agents relevant in a use case like that? Or do agents only become relevant if you add a few more workflows on top of that classification? Only then agents kick in. Where do agents start kicking in?
So agents are particularly helpful when we have a distinct kind of pipelines for each agent to work on.
Hmm.
So in this particular use case, I wouldn't think that agentic framework would be really helpful, because
Hmm.
each agent will call the LLM to process each claim. That would be
Hmm.
really like cumbersome and not cost effective. It will increase a lot of latency and a lot of cost. So in my opinion, agentic framework are really useful when we have like a separate set of instruction for each agent that can work on its own and provide
Hmm.
a collaborative environment for other agent as well.
Hmm.
I think to answer your question, in my opinion, this wouldn't be agentic framework wouldn't be helpful in this particular use case. Could be possible in the near future. I'm not sure about that with the other architecture that come into the play. But with the current trend and the current use case of the agentic frameworks, especially like the land graphs, I don't think it would be useful, because each claim is different and each claim requires a lot of pre-processing. I don't think that would be really helpful to utilize each LLM call for each agent to uh, process the information that it has.
I'm sorry, I said one question, but I have one more final question because
Yes.
the biggest concern people have with LLM. I mean, unless they are deep into it, everybody's
Yeah.
always thinking LLMs are costly to train and fine tune and things like that.
Yeah.
And you mentioned a very specific number 10 minutes back. You said with Mini for 1 million call records, it's $550. Could you just elaborate a little more on that? I didn't quite
So
fully get
that
that.
was yeah. So that was a use case with GPT-4o Mini that just
Ah,
came out. So
yeah.
with GPT-4o Mini, the cost is relevantly cheaper. I'm not
Mm,
sure what's the exact cost for the input and
yeah.
output tokens, but
Yeah.
I read a use case and we did test it out that for the million call records, like what I meant by call records, because we have this particular project in our current company wherein we're basically utilizing call transcripts to automate a lot of stuff to make it in a structured manner and extract some key entities. So
Yeah.
what I meant by 1 million call records that costed $512 was that to utilize GPT-4o Mini on
Yeah.
these 5 million records, sorry, on these million records, it costed only $512. Whereas if we compare it with the traditional GPT model, GPT-4 model or 3.5 turbo, it costed almost like $1,000, $2,000, more than 100% of the GPT-4o Mini cost.
When you say call records, you mean call recording transcripts? That's what you
Correct,
mean. Okay,
correct,
understood.
correct, correct, correct.
Okay, got it.
Yeah,
This has been super helpful, Gagandeep. There's been tons of incredible information here. Thank you so much for sharing this with us.
absolutely. My pleasure. I mean, thanks for having me, Binny.
Thank you.